laptop.
$400.
Yeah, very cheap.
Just throw your money on furniture.
No. I get a workstation. I get
A workstation is very expensive.
No. It's getting cheaper because
Yeah, you get a 64 GB RAM machines for 3,000.
Yeah, no.
It's $400.
Lenovo has one with GPUs. You can have something like $2,000.
No, I'm talking desktop. Yeah, I'm talking about desktops. Yeah.
Yeah, it's like a desktop. It looks like a desktop that has GPU and so on.
Mm.
And basically, you can upgrade. You can add GPUs to. You can spend as much as 20,000 to
Yeah.
upgrade it, of course.
But what is the basic specification?
I get to, for example, 1 GB SSD.
Sorry, I apologize for being late, guys. Got caught on I-4, just sat for a long time.
Just introduce you briefly and you can...
Sure thing, however you want to handle it.
Yeah, okay. Thanks everybody for being patiently waiting for Bob. I just wanted to quickly update him. He is currently the Director of Planning and Innovation for the Tampa Hillsborough Expressway Authority. He works on different projects including the Connected Vehicle Award for the USDOT Automated Vehicle Testbed Certification. And I'll let him speak about the projects he's working on. Thank you.
Thank you. Hello, once again, my name is Bob Fry. I apologize for making you sit here. I feel terrible. But a combination of I-4 and never being on this campus before played into this. So I'm basically Director of Planning and Innovation over at the Tampa Hillsborough Expressway Authority. We're a toll authority. We're like Central Florida toll authority that you have over here. We're an independent toll authority, which means we get no tax support whatsoever. There's no state or federal dollars that are used for our agency. So basically, everything we do is with user fees through the tolls. I know we're going to talk a little bit more about smart cities and stuff, but one of the things I guess I wanted to get across, being that this is a university and most of you guys are students, is smart cities, ITS, if you're going to work for an agency, it's going to be a very small part of what you do during the day. For example, right now we run the CV, I'm doing the CV pilot, but we have most of you guys civil engineers in here, electrical, what are you? What Between? A mix? Okay. Right now I've got, are you familiar with the term PD&E? Project Development and Engineering? Okay, I've got four of those going right now. Plus we own a trail that we have to make pretty. So you're doing the trail type stuff as well. Plus one on the toll road, so you have all the things that you need to do as well as that. So the smart cities part of your day, it's a small part of everything that we do. And you got to realize that when you're going to go into public agency work, especially you civils, you're not going to be able to spend time just on one thing. It's a depth of about this deep and as wide as this room, as opposed to the other way. In school, you guys have been going into really in-depth into things. So we'll talk a little bit. Right now, we own 4 facilities. We have the Leroy Selman Expressway, the Selman Greenway, and 2 arterial roadways that we also own and maintain. We're in the process right now of building the Selman West Extension, which is a 2-mile bridge that will connect our system to the Gandy Bridge as well. And the Connected Vehicle Pilot Deployment. USDOT put this out in 2015. We're one of 3 sites in the United States that were selected for this. The other 2 are Wyoming and New York City. We're all looking a little bit at different things. Basically, what we're trying to do here is spur the early development of CV. This is a pilot, so things don't go as planned. You're basically pushing things, forcing your vendors, forcing the people who are actually building the technology to move beyond where they've been before. So you're going to get answers that you're not going to like. Some of them are going to be, no, this wasn't a good idea. So and you have to report that. The second thing we're doing is we want to measure the benefits. As I said, for my agency, we don't receive any dollars from the government. None of your tax dollars go to us, which means whatever we spend our toll dollars on has to produce. It has to be value. It can't just be there because we think it's a good idea or we think it's cool working with other. It's got to provide something. And how do we determine that? We have to measure it. Performance measurement and metrics. University of South Florida, Qatar, the Center for Urban Transportation Research, is actually doing that part of our project. And then finally, we're looking at how do we resolve deployment issues. And believe me, there are a lot of deployment issues. This technology is nowhere near as mature as they'll lead you to believe. Oops. Go back here for 1 second. We had 12 months to plan it. So basically, our partners, which are Brand Motion, Siemens, H&TB, and then we have some communications firms that are working on it. The vendors who are actually building the onboard units are Savari, Consignia, and SiriusXM is actually involved, and they're building 100 units as well. But we had a full year to put the concept development together, 20 months for design and deployment, and then right now in September we just went into our maintain and operate, which is our performance measurements. We're measuring what's going on. So we have all of our roadside units are out. We have 44 of them hung, well 40 of them, 4 more that are going to be hung as soon as construction is done on an FDOT project. And we have 900 onboard units in vehicles, in volunteer vehicles around Tampa. Are you familiar with, our project is a DSRC project. So we're using direct short-range communication. I'm sure you guys have probably hear about the cellular versus 5G versus DSRC argument that's going on all over. And why do we choose DSRC? Well, number one, it's available. It's here. We can actually install it. I joke, I give the telecommunications guys a hard time. I call it the mythical 5G we're still chasing it. Someday it may be here, but right now I can't deploy 5G. Toll roads have been using DSRC for 50 years. All our inlane equipment, all the equipment on Central Florida and the Florida Turnpike, your tolling equipment is DSRC, and it works. Our level of, our standard that we hold our toll providers to is, and I'm talking about cars going underneath the gantries that you see on the roadway. We miss 3 vehicles per 100 million. That's a pretty, that's a pretty high level that you have to be able to maintain. In addition, our contracts with the providers of that is if their equipment fails and we lose revenue, they replace it. So think about that. We're only missing 3 out of 100 million, and if it goes down, the company pays us back for it. They're that confident that the technology is going to work. Can't say the same thing right now, telecommunications and anything. We actually met with one of the telecommunications firms, and they wanted to get into the tolling industry until they sat down and looked at the contracts and looked at the standards that they would have to meet, and decided they were not ready to sign those type of contracts yet. Their technology's not there. So that's why we're doing DSRC and why we're pushing it. The other reasons are latency. DSRC is quick for public. On the public agency side, we operate 365 days a year, 24/7. So whatever you put out in the road has to work. The firms that you hire have to have what I call bench strength. It has to have the depth of service to support that. So, for example, we had an application. Really, a lot of these startups, the small little companies you see breaking away that you hear about all over, brilliant people. We had one on an application we were going to use at MacDill Air Force Base on our roadway. Great idea. Using satellite technology, we were all excited about it. But they didn't realize in a public agency, 365 days a year, 24/7. When we first started that project, man, those guys were all energetic and all excited. By month 3, they needed to be committed for arrest because there was only 5 of them. So every call, everything that broke down was one of them. Sunday night at 2 a.m., guess who got the call? They didn't have enough depth to support what you need to support. So one of the things when you guys are, in your classes and you're thinking about these great ideas and how do we put it together, operations and maintenance support has to be taken into consideration because that's what's going to make or break it. If it works great for 15, 20 minutes, works great for a month, that doesn't help me. I need something that's going to work all the time because the expectation of the public, and especially in public safety, is it's going to work every time. And if it doesn't, somebody's life could be affected or it could cause a crash or something along those lines. So basically, we've equipped the vehicles to receive data. The vehicle information we're looking at from the this is V2V, vehicle to vehicle, location, head and speed, and path history, so we know the trajectory of where they're going. We use traffic controllers to monitor the data and measure traffic conditions. At this point, I want to bring this up. How many of you guys are familiar with Waymo? Everybody heard about Waymo and how they want to put autonomous vehicles out, and they're willing to do 300 of them. But they don't want to connect to the system. They want to keep it to themselves and all the data. And we're seeing a lot of that with the technology firms. From a public agency perspective, I got a problem with that. Number one, the only benefits that I can get from my system is increased safety and efficiency. So how do we do that with the connected vehicles? Well, the information has to come through my traffic controllers. It has to go to the traffic management center, and we have to use it and be able to get out there and see what's on the system and then make changes and adjustments as things go on. If I've got 3,000 autonomous vehicles running around that are not connected and they're all self-contained, it does no good. All you're going to do is be sitting in one big autonomous traffic jam because we're not able to do that. The other thing you have to look at, too, is from a public perspective, is social equity. How do I spend toll dollars or tax dollars on autonomous connected vehicles if the only people receiving the benefits are those who can afford those vehicles or can use those vehicles, who have the money to buy an Uber or a Lyft or whatever? Now, if you connect to the system, to Orlando's system, now your pedestrian signals are starting to be able to take advantage of it. Your traffic signals are, so all these people who are just using your roads are able to. Traffic efficiency gets better. So it gives me, it's an avenue, connectivity is an avenue for the public sector to take advantage of this and to get involved in this autonomous connected vehicle world that it's coming. And I'll give you a little, this is a true story. We were working on, in toll roads we have back office. That means basically the money part of it. We have a transaction, we reconcile it against your credit card and then bill you. Well, we were upgrading that. My executive director and I were talking about this project, about putting together the proposal, and in the back of the room, one of the engineers, who's a German engineer, said, "Hey, you're talking about autonomous vehicles and stuff?" And I said, "Yeah, we're looking at getting in that." And he was like, "My first job out of graduate school was working for Mercedes-Benz in 1974 on autonomous parallel parking." 1974, which is probably about 20 years before any of you guys were born. That's how long the auto industry has been trying to do this. The technology is now reaching a point where it's actually possible. So think about Google, Amazon, Mercedes, Porsche, all these huge companies, GM, Ford. Think about that much time and research that's gone into this, and then think about the money pushing it behind it. It's coming, guys. Whether we like it or not, it's coming, and it's going to happen because they want it to happen. And they're going to push it, and the technology is going to be there. So how do we use it to help the system as well as people? I mean, don't get me wrong. I mean, I'm just as big into, if I'm taking a trip from here to Seattle, being able to go into autonomous mode for half of it, is a pretty good, I have no problem with that. Although I do like driving, so I'm not really sold that we're all going to give up our cars and we're all going to sit in these little pods with our earphones in, together. I like stopping at Starbucks. I like listening to different type of music than you do, and I like my Dodge Charger that has the 500 horsepower engine in it. Sorry, I'm not going to give that up. Go to Texas sometime. Tell me if you think they're giving up the pickup trucks. So you're going to see the same type of number of vehicles on the road, but rather than 90% right now being personally owned vehicles, maybe 50% are. Maybe 40% become these type of autonomous shuttle things that you start seeing around that work. That percentage will change. But personally, I don't believe it's going to take a long time to get to the point where people don't want to drive. Does anybody here have a car that they like? I mean, it's funny. I know a guy who drives a 1968 GTO. I don't know if you know what that is. Yeah, the judge. But his the comment was some things just should not be automated. I mean, and so I believe that there's areas that will work. Campuses will be fantastic. Downtown, central business districts and stuff. But trying to connect between Orlando and Tampa, that long ride, I don't know. I mean, we'll see. Because with this autonomous stuff and with giving up your vehicles, we lose freedom and we lose the ability to do it the way you want to do it. Because now we got to share with everyone, so it makes it a little bit difficult. And when I'm in D.C., I don't ever rent a car. D.C., New York, Chicago, any of those big cities, I never rent a car. I'll Uber it and take cabs all the time. When I go to Texas, I rent a car. Actually, Austin Airport has the best selection of cars. I just rented a Camaro that was just normal one, yeah. Anyway, so the traffic controls, we've got to connect this into the system to get the benefits. And that's why we're pushing connectivity. And once again, I got to stress, I'm a public agency. The guy from Google is going to sit here and tell you the next time your professor sets up the talk for the Google guy to come in, he's going to tell you all the benefits of why what they're doing is better and they can do it better, more efficiently, and get it on the road quicker than the public agencies. We can't. We're using public dollars. And then finally, the security mechanism, it's there. Everything can be encrypted through the DSRC. And as I said, we have a long track record in the toll industry of protecting people's personal data, your accounts, your credit cards. DSRC is very, very difficult to break into. The cloud, is another issue. So the other part of this we're doing is, I say, yeah, please.
Hi, about the vehicle information, how the location or path history is determined.
Excuse me?
In the previous slides, when we talk about the vehicle information, their location information, their path history, how's that determined?
Well,
GPS.
Well, we're using three things. Number one, every roadside unit at every intersection has a map. The mapping is going to be the hardest part of this autonomous thing that you see coming up, because basically maps change. So think about work zones. Work zones are going to be a nightmare. Every time you change a barrel, guess what? Your map's got to change to reflect that, because otherwise you're providing the wrong information to a vehicle. So you're going to start seeing, in my opinion, DOTs and people who maintain roadways start bringing software engineers on, and you're going to start seeing mapping come in as part of their typical job. And 10 years ago at a DOT, you'd never see a software engineer or anybody who did mapping at all. So you're going to start seeing changes to that. So we have the map from the RSU, we have GPS in the onboard unit that matches, and then we use dead reckoning and the other RSUs to triangulate to tell them where they're at. The New York City pilot is really interesting because they've got those urban canyons. So how do you do it without line of sight? So they're trying to figure out how to use repeaters, and it's much more complicated for them. They're doing it in Midtown Manhattan, which is like a nightmare. The amount of data, vehicles, angle, it's just, that one is actually behind schedule, which I'm not surprised. But the other thing that we're working on is V2I, and this gives you the geometric information. You stop bar your lanes, your permitted movements at intersections. So it tells the car and the OBU what it can do and what it can't do and where it is. And it's talking to the roadside unit all the time to let it know. One of the things we wanted to do in our pilot when we first started was use cell phones. We were all excited about using cell phones. And then we found out that the GPS in a cell phone is horrible. You're talking up to 3 meters margin of error. Well, if you're using it for Waze and you're traveling between here and Seattle, that's fine. When you're talking about a crosswalk with a person, 9 feet can make a huge difference on where that person is or not. So we actually, our first 2 findings of our pilot was that the cell phone technology was not ready yet to help with public safety because it's just not accurate enough. The other thing is the amount of data that kept flowing back and forth between the RSUs kept setting the RSU and the phone into reboot mode constantly. So you're constantly having to reboot. Yeah, go ahead.
I have a question. So
Please.
what happened as you start deploying these technologies? Some location will have the technology, others will be like isolated kind of technology-wise. But how the optimization of the whole network will happen if you take quick decision in a certain location that will affect other locations that don't have the technology?
Well, I'm going to get to that. I'm going to build it and show you where we're at and where we're going with that. But yeah, it's so SPAT, signal phasing and timing. That's your signal data that we're submitting to the vehicles. Time when it turns yellow, when it turns red. Just basically telling the vehicle when it's going to do things. And they receive the data, determine immediate infrastructure issues, and then we alert the driver. Right now, we're not dealing with autonomy at all. We're just giving driver information to make decisions. Ultimately, the two are going to intersect. When? I think it's more of a political decision than it is a technical one because right now the technology's close, the ability's there to do it. Politically, when are they going to pass laws that allow them to do that and it not become such a liability issue that you're going to end up in trouble? But it's definitely going to happen. Our DSRC, we work on the 5.9 gigahertz that's set aside for connected vehicles. These are our channels that we're operating on. One of the things we did learn is that this is not as protected as you might think. We have amateur radio who's using it, and they're allowed to use it as a secondary user, but they can't interfere with us. Well, guess who the burden of proof is to tell that they're interfering? Yeah, me. So now it's another thing I have to worry about, and I have to hire someone to come in monthly and check to make sure that everything's operating and they're not showing up where they're supposed to be. So it's another one of it's an FCC rule that you have to worry about on that. But these are the service channels we're using, 5.9. To some of you electrical guys, it probably makes more sense to you than me. So why DSRC? We're looking at improving the operational efficiency of systems. We have a track record, security, safety, and the ability for all residents to experience it. So that's why we made those decisions. Here's our deployment area, basically Central Business District of Tampa. The purple road right on the New Zealand Parkway there, that's the reversible lane segment of my roadway. And it comes down Meridian Avenue, which is the focal point. And we're doing all these different applications. Originally, when we talked about this, a lot of stuff was being done like one application per intersection. Well, in real life, things don't work that way. You got a lot of problems at intersections, and different intersections have different problems. So we actually tried to do that. So if you look at the different locations, we had our general engineering consultant, H&TB Corporation, go out and we did safety audits and traffic engineering studies at these intersections to find out what were the problems and could the connected vehicle technology help solve them. So that's why they're at the different locations. You know, we have engineering to back up. We didn't just pick and choose. I was I didn't want to do that at all. So as you can see, we're looking at traffic flow and optimization. We have a bus priority, which is sort of interesting. We help the buses go through the green time. Rush hour collision avoidance, wrong way entry. We're trying everything. We even have a streetcar, which I'll show you in a second here. Here we go. So the goal was 1,600 privately owned vehicles, which we were going to bribe them. We gave them a $500 discount on their tolls. We got 1,000 is where we ended up at. 9 Tico streetcar trolleys, they're all hooked up. Those were more of a pain than you'd think. It seemed like a good idea at the time at like 2 in the morning when we're putting this thing together. It seemed like a good idea, but the number one, they're historic. You can't drill into them. You can't do anything with them without going through the historical society to make sure you're not hurting them. The electrical systems were designed in 1912. So trying to hook up a 1912 electrical system to 21st century technology is a little iffy. They go both ways. So each one requires 2 onboard units, one in the front, one in the back, and then a little switch. But literally, it's just a little switch that you go like that, and then it's going this direction, or you go like that, and it's going that direction. Well, they're on rails. You ever heard of the Federal Railroad Administration? They have all sorts of rules. Anything on rails goes through them, not through DOT. So we had to put together a week training for the drivers for them to flip the switch from this way to this way. Bureaucracy, it's ridiculous. They had to go through OSHA training for the occupational safety stuff. These are all things that you don't think about sitting around here in the classroom when you're putting this stuff together. This is a cool idea. How do we do this? And then you go out there and find out what? You're kidding me. But it adds time and money to the cost of getting something to get it out on the streets because you just don't think about it. We have 10 buses, and those are the roadside units, the 44 of them. Siemens produces those. The vehicle interface we're using, please.
Did you have any issue with the temperature? This is like hot weather. Do you have anything?
No, we haven't had that. Actually, we've had a lot of companies like to test on our facility and stuff. Not because you think they want to test because it's nice weather. It's just the opposite. They want to test because during the summer it's hot as hell, and the rain. They love that we get these deluge storms, but they're gone in 20 minutes. So they can actually test something and then reset it and wait for the next storm to come and do it. So we've actually had a lot try to do it. They like our weather for that. We have not had issues with heat being an issue on that on any of this. We're using our interface. We're using mirrors for several reasons. Number one, we were going to use tablets, but we learned the difference between consumer grade and retail. Our original budget was based on retail, which is what you buy at Best Buy. That tablet is not heavy duty enough to stand up to what auto grade, what your car goes through. So it will break in 2 or 3 months if you use that. So when we looked at the auto grade, which is basically the equipment you have in your car, it's much more expensive. It's tougher, but it's much more expensive. That would have blown our budget. The mirrors were cheaper, so we were able to keep our budget and use them. The other thing is, everybody knows how to use a mirror. Even my 16-year-old son, who can't drive to save his life, knows how to use the mirror. So you didn't have to worry about distracting drivers, turning their heads, learning a new behavior. If you want people to do things, what do? You keep it as close to their normal routines as possible. You don't add something new. So that's why we did that. I'm sure there's groups out there who will tell me this is the exact wrong thing to do. You're going to learn that too, guys, when you get into this. Whatever decision you make to a certain portion of the population, it's wrong. There is no 100% right answer or wrong answer. You can believe me. These are our graphics. Several of them we had to create for our project. The trolley over there is actually a new one, and this one here, the wrong way vehicle, didn't exist, so we had to create those, and they do now exist in the US DOT catalog that you can use. So we're sort of happy about that.
That wrong way vehicle, that's warning you of another vehicle that's coming the wrong way?
No, if you're going the wrong way, first thing you're going to get is the do not enter.
Okay.
You're in the wrong ramp, you're going in, you're going to get a do not enter. Once you go past that, you're going to get wrong way. That you're going the wrong way, and that's going to stay on for as long as you're going the wrong way. When you pass the point of no return, all vehicles coming in your direction are going to get the wrong way vehicle.
Okay, so that's telling you.
So yeah, I'll have the wrong way because I'm going the wrong way. You coming at me, you're going to get the wrong way vehicle saying that you got a wrong way vehicle coming at you. That's the concept.
So, is it only visual or is it this kind of beep or sound also?
Well, you get there's an audio portion that you can use. My executive director wanted the wrong way to give you an audio signal and just keep getting louder and louder and louder and louder and louder until you finally went the right way.
Have you guys considered something haptic in the steering wheel?
But that's
Like a buzz to alert the driver to look in the mirror?
the vehicle manufacturers, the OEMs are doing that. We didn't have the capability of doing that. One of the things we learned from this project was that the automobile industry and the telecommunications industry, they don't want to cooperate. Are you guys familiar with something called the CAN bus? In the vehicle, the CAN bus in your vehicle basically is your master control bus. Everything goes through there. If you could access that, you could access all the data in the vehicle. We were not allowed to touch that. Everything we had to do had to go around the CAN bus when we retrofit because the auto manufacturers were going nuts. So yeah, that's why I started out with the Waymo and stuff and preaching connectivity, because there's groups out there who don't want that. They want their data and then they want to sell it to you back. So we have morning backups. For this particular use case, we're using forward collision warning, electronic brake lights, which means when someone hard stops in front of you, you get the message. End of ramp deceleration. As you're coming to the end of our freeway, you get the different speeds of what your speed should be coming in based on the actual queue. So the difference between these and some of the others is they're dynamic. They're measuring the queue and then giving you the warnings where they should give them to you, as opposed to just being binary on-off. And then the intelligent signal systems. This is interesting because University of Arizona wrote this IC, and we're using it. 2 years into the project, we're in Tucson, Arizona, at University of Arizona on a meeting trying to figure out how to get this thing to work. And they drop on us that, well, you need like 80% saturation rate of connected vehicles to make it, it's like, you guys couldn't have said this 2 years ago. We ended up having to use video detection to supplement the data. So right now we're getting 10% connected vehicle data that's helping our signals and 90% video. As the years go on, we're expecting that to shift to more connected, less video. But the lesson there is your existing ITS, intelligent transportation systems out there, your existing ITS can support this technology and help it along until we get to the point where there's enough of it out there to actually work. We did wrong-way drivers, as I just explained before. Pedestrian safety, this is another one. The two apps that we wanted to do, the PedX, we had to cancel because we couldn't do it because of the cell phone. And the pedestrian collision warning, which is at this location here, that's a courthouse, so we get a lot of people moving back and forth. We had to supplement it with LiDAR. So we've got LiDAR, which is very, very accurate, telling us where the person is in the crosswalk, and then that LiDAR is reporting back to the roadside unit and then pushing it out to the vehicles. So it's another example how you can use existing technology to help this stuff along until we get to the point where it's not needed.
But pedestrian can cross anywhere. They can cross in the mid-block or something. Then the technology is limited.
Well, yeah, but we're staying within the law.
Yeah.
The law says you're going to use crossing the crosswalk. I can't cover everything, guys.
But that's safety. yeah, that's true. But I'm just.
But yeah, it's funny on this one. I'm sitting here watching this. We're putting all this stuff up, and I'm like going, wouldn't it be cheaper just to put 2 fences in and just make them not be able to cross there? They could cross down at the same.
They jump actually.
I had an answer to that. You guys ever heard of bougainvilleas?
Yes.
The big ass thorns on them.
Yeah.
So they can electrify them.
Oh, I don't know. He's more extreme than I am. Man, I'm just gonna plant thorny plants there and electrify them. That's. And then we have the transit signal priority. This is interesting because they only get the green time if they're falling behind the schedule. So the application is looking at the schedule, looking at it where it is on the map and in terms of time. If they're on time, they get a red just like everybody else. If they're behind schedule, we extend the green time to get them through, to get them back on schedule. So I thought that was sort of interesting. And this is a streetcar. These things are the biggest pain you ever deal with. I mean, and of all the applications, probably the least amount of value here. It just doesn't do a whole lot. But Discover Canada came and did a 20-minute piece on our pilot. At 20 minutes, 16 minutes was this. They love it. They love it. So if you need a mascot for your project, trolleys are great. In terms of practical transportation, it's just. And then we did the traffic progression as well. You guys familiar with this? Any of you guys doing systems engineering at all? If you are an engineer, or even in any of the hard sciences, and you're looking for a master's degree, I would strongly recommend systems engineering. The reason is you can use it anywhere. You can do everything from cancer drugs to build planes, and they all use the same systems engineering process, and they hire based on that. University of Arizona has a program that I'm working with on ISIG. I didn't know this until I was talking to Dr. Larry Head, who runs the program. West Point, the Naval Academy, Annapolis, and Air Force Academy all send their master's candidates to Arizona. Systems engineering is what they're training, because once you learn the process, you can use it anywhere. My son's at the Merchant Marine Academy, and I'm telling him the same thing: get the master's in systems engineering, because you can use it for everything, and everyone understands it. But you start up in your level 6 needs and feasibility. We've went through all phase 1 concept operations requirements, phase 2 high level design detailed, went through the software, hardware, units, devices, subsystems, all the way up to system validation, which we did in July. We had a big demonstration, and then we're now in operate and maintain. This diagram here with all this stuff here was put together by Siemens. This is what they use to manage their projects. And I don't know if you guys know who Siemens are, but they're a pretty big company. By the way, I don't usually talk about this stuff in my normal presentations, but you guys are students in school. And if you don't want me to talk about that stuff, I won't. We're in performance measurements right now. So basically, the Cutter server. Are you guys familiar with Cutter? Okay, Center for Urban Transportation Research. The Concert system, this is the Siemens master system where everything comes into. And then we have the Next Connect, which is the traffic signal coming out of here. Next Connect is the transit. Then we got the third party stuff that's coming in. And we have the weather, waves, Bluetooth, all that. And Centrex is out of the traffic controllers. So all that data is going, fire hosing it all the way back to Cutter, and Cutter is then turning that data into performance measurement and how the stuff is actually working. So in the traffic management center, you all guys know what a traffic management center is? Anyone? TMC? Basically all your signals work there. They're the places you see on TV where they have all the screens. If you ever saw the movie Traffic, the one they hacked into, that's the TMC. But we have a dashboard there, and we try to do other things as well. We have level of service. We can do vehicle counts on there. Each one of these numbers is a roadside unit and location, so we can see how they're operating, or in this case, if they're down. And then basically the intersection Q lengths, you can tell. So we've got all these different stuff so that this technology is providing more value than just the V2V and the V2I. Why do we do that? Budgets. Because to get things funded, the more it can do, the better chance you have of getting money to do it. Another little tip to remember for your careers, make sure it becomes a line item in the budget. That's how your funding gets in. Every year when we do work program, the line items get funded. The individual projects, they get scrutinized like crazy. But once you get it accepted, get it in there as a line item. That will help keep your funding going. Then data generation. Right now, this was from September 23rd. We had 657 participants at the time, and it just shows you there basically how many hits in millions we're getting. July was when we did our testing, and then now this is when we went operational. But it's the database is basic safety messages, STAT, which is certified phasing and timing, TIM, which is traffic incident management, and then all this is coming into this, providing that. This here shows participants. This is the basic safety messages in millions that we experienced on a particular day. This right here is basic safety messages as well for a different time frame, different way that they're looking at it. Cutter, you guys, if you're, I'm going to get in trouble for this one, but academics will drive you nuts. Right now with the performance measurements, they want to make sure everything is statistically valid and go through all the proper stuff before they put it out. From my perspective, I don't need it to be at that level that an academic institution needs. So I'm like begging for anything you got. Give me a trend. Give me an observation. Anything that I can put out. And they're all, no. We got to make sure. We got to make sure. So wary of academics. Travel data. This here is we did 1.7 million BSMs a day, and the weekday travel patterns. This here shows, for example, number 7, 8, and 17 are all on our reversible lane segment, which we know the most participants come through every day, so that we're able to look at it and field truth it. Or is the data we're getting matching what's in the field, and is it real? If RSU 5, which is down by the transit center, starts spiking, showing much more than what we're seeing on our toll road, we know we got a problem, and we need to figure out what it is. One of the things we did in our pilot that has never been done before, another one that I'm proud of, is prior to our pilot, you had to take your OBU back to like a car dealership, and they'd hook up to it and download the data, and they do all the firmware and software updates. We're doing it over the air. So when you drive along the Selman Expressway coming in, it takes 10 RSUs. So it's we have a reversible lane segment that's 12 miles. Once you get on, you can't get off for 12 miles until it drops you off in downtown Tampa. So over that 12 miles, it updates your software and firmware so that you go over. And nobody's done that before this project, which I sort of think is sort of cool. This is what I was talking to you about earlier when you were talking about building the system. This is downtown Tampa. My 44 RSUs, or 40 that I got in the street right now, cover this much of it. So our next phase is, how do we put out more RSUs to cover the rest of it? And that's how we're going to have to get that whole system up, is building it phase by phase, building into it. Right now, we're doing a pretty good job. We're covering a lot of, I would say probably close to 65% of the downtown is with the RSUs we have.
So this BSM is per day? You have this
Basic safety message.
No, are you getting this number of BSMs per day from these?
Yes. Yep, BSMs per day per million. So getting them in the different areas, and then the other one we're getting here is what we call a heat map, which is pretty cool because it shows at 6 a.m. You see how green it is. 7 and 8 we get slammed, and then by 9 and 10 we're starting to come back down. Now, what we'd like to see at some point, which we call is expanding the shoulders, we'd like to start seeing more pushing out and coming down so that you're not constantly just getting slammed in 1-2 hour period, which makes it very difficult. Because then you're building infrastructure for a very short period, and then it's sitting vacant for a long time. So we're trying to figure out ways to do it. Being a toll agency, we do it with pricing. But I don't know if you guys have a lot of economics or not, but I'm a Milton Friedman guy. We like using pricing, dynamic pricing, to get the behaviors that we need. Go, please.
One question for the safety before I forget. So So have you tried to compare, for example, when there are many of your cars on the road and how many messages you get, and when there are fewer cars, and you see if there are any improvement in safety in the intersection?
We've been collecting data now since September.
No,
But what I'm saying is, once we get next year at this time, yeah, I'll be able to sit down and have slides showing you how things went. Did the average delay of the roadway improve? Did we have less crashes? Did we have less fatalities? That stuff I'll be able to tell as time. Right now, I don't have enough data yet. Right now, we're just, to be perfectly honest with you, we're happy as hell that we're connected. We're showing that the equipment is out in the street and it's working and it's actually starting to show and we're actually starting to measure. So right now we're at a very nominal level of, we're just able to show very, very generic things. As it goes on and they start tweaking it, we're going to be able to really start getting into it. And that's what the goal is for us to really dig down there. They want to be able to show if we made emissions differences. Cutter will be measuring that. I mean, I don't know how, but they're going to. Go ahead.
But for example, let's say for the safety measures like brake and so on, before even waiting, would it be even useful to be, for example, stay a few hours on site, collect some data, observations, and then compare to what you get from the system as a term of validation?
Yeah, we're doing that right now with testing and demonstrating. Sirius XM, Solari, Siemens, they have people out there all the time tweaking it, trying to get it to work. They're using it more for validation and calibration right now than for determining if there's any benefits. And then that takes me back to my academic comment. They won't let me say anything because they're scared to death. I'm sorry, I'm picking on you. I shouldn't, but
They're all professors actually. So
the what?
There are a lot of professors in the class in the room now.
I think there are more professors than
Students.
Oh, okay. I'm gonna get yelled at then. But it's the truth. It makes it difficult. So anyway, when you want to, we're going to talk about data. 70 billion connected devices and sensors. This is what we generate. The one thing I have to say on this is predictive analytics are going to be huge going forward. Because how do you deal with this every single day? And how do you turn it into anything useful? It's just so much. It's overwhelming. You're going to have predictive analytics that are going to be able to go through this and pull what it needs out of there and disregard the rest. And that's what we're working on right now on how do we do that. But yeah, I mean, when we talk smart cities and we talk about all this stuff, and it's really cool what it can do, they don't think about the other side of it. It's going to be difficult to manage that much data and to actually have it be useful. I have like 4 big data firms a week come into my office and want to sit and talk and tell us what they can do. And my executive director always has the same question for them. Does it produce anything of value, or are we just measuring it because we can? And too many times the answer is, we can do this now, so let's measure it. Okay, and they want us to pay money to do it, but it doesn't provide anything. And I think the problem is just so much. It's very, very difficult to go through that and figure out what it is out of all of those 2.5 quintillion bytes is useful and can actually be used. And that's probably where the technology firms definitely have an edge up. They're able to do more of that, but we have to figure out a way to get them to play so that we don't have to pay for everything. And then this is how we upload everything every day to Cutter made me put this in. I have no idea how they do it, but they do night batch jobs and stuff. I got 3 slides here on what we would do over again. I don't know if it means anything to you guys, but I'll go through some of them. The standards are changing constantly. When we started, there were no standards. Now they got standards, and it's every month you're getting another U.S. DOT, connected vehicle, automated vehicle new policy. So trying to do this makes it difficult because it's a moving target. And you guys are the ones that have to sit here, engineers are the ones that have to design to a target that doesn't move. We actually built our maps originally to the European standard because they had one. We didn't have a standard in the United States. They had one, so we used that. It turned out that US DOT said no, and we had to go back and redo it. They wouldn't let us use that one. But I mean, that's the situation we're in right now, is that this is a moving target. The available application maturity, a lot of the salespeople will sit there and tell you that they can do all this stuff, and they're lying. They can't. For this to really take off and become, for smart cities to really take off and be all over the United States, which is ultimately what you need to have, it has to reach the point that we do with traffic signal controllers. I could switch out 10 traffic signal controllers in a day and be up and operational and not lose anything. Right now, every RSU is taking 6 to 8 months to modify to work at a location. That's not going to cut it. Number one, the local governments don't have the time and the money to invest in that. And number two, you can't have the system keep going down. It's got to be up. So we really need standardization to the point where you can do that, where you can pull out one and put in another, and that's where it's going to go. And it's going to happen. When I first started this project in 2015, now granted, it was a DOT pilot, and there was a lot of development costs because we didn't have any of this stuff. But each of my RSUs probably cost $250,000. Now, if I want to put in a new one, Siemens gives me a price of $12,000 installed on location, hooked up to the TMC operating. So we went from 2015 $250,000 to 12 in a short period. So it's going to get better, but right now it's not there, and they're going to have to deal with that before smart cities becomes a reality. And we could talk about all the great things that it does, but if you really want to think about it in terms of, I went to Baylor to graduate school, so I keep going back to Texas. That's where my first jobs were. In West Texas, you've got a whole bunch of little towns, and each of them have signal shops, and they all have engineers sitting in there. That guy's got to be able to talk at the same level and be able to operate as the guy in New York City who's doing 50,000 signals. And right now, it's not. And the other part of it, too, is going to be cultural. I'll never forget this. Any of you civil guys, you ever heard of a software called Geopack?
Oh, yeah.
Okay. In 90, I'm dating myself here. When I graduated, I was working out in the Texas Panhandle, and Geopack just came out. And the sales guy came in and gave us a presentation and showed us how you put everything in, and Geopack will design the road for you. And the curves and all the tangents, it will figure everything out. In the back of the room was an old engineer out there who was literally playing with a slide rule, whose response was, "Where the hell's the fun in that?" And he's like, I used to work, he used to work in the aerospace industry, back in the 60s, and then he moved into roads and stuff. He goes, I like going out and figuring out how we're going to get over this hill and how we're going to get around that. He goes, I don't want a computer to do it. So you're going to have a portion of the population of engineers and stuff at ITE and all these guys that actually don't want everything automated and being done for them, where they're sitting around and basically just monitoring screens all day and pulling a Homer Simpson. That's just not. So you got to think. How do we work it where we get the benefits yet maintain some of the ingenuity, individualism, and stuff that we had as a country that helped get us to where we are, without just becoming so reliant on things. And these are social questions, I understand, but it is something to think about. I mean, I'll never forget, that guy stuck with me my whole life, and he was just, everyone else was blown away, and he was just like, screw, I don't want to do that. So, I already talked a little bit about the understanding the vendor's depths and resources. They got to have the bench strength to get stuff done, or it's useless to you, at least to me as a public agency. Device certification, right now everything's being certified through something called OmniAir. I don't know if you're familiar with OmniAir, but OmniAir is a consortium of basically different electronics and telecommunications firms. But every device that goes out has to be certified by them. It was supposed to be a 2-week period. It took us 9 months to get our devices, and all of them are not even through yet. Siemens got through, and Consignia did. But they need to come up with something better than that. All right, what else do we have? I would strongly recommend doing integrations testing before you start involving stuff in vehicles. And if you're going to get involved in installing stuff in vehicles, don't. Hire someone. It is the biggest pain in this whole thing is not the roadside and the infrastructure stuff, it's the vehicle stuff. Trying to get these onboard units into vehicles and getting them to work is where everything is falling down. The roadside units, I mean, I got 42 out of 44 up and operational. I mean, I could live with that. But go ahead, please. Yeah.
No, but what's your strategy if you say that Porsche and Mercedes don't want to cooperate? And I understand because the technology is changing fast, as they want to keep it for themselves. So it's understood from their perspective. But how are you going to get the vehicle side to work in practice if none of the vehicle will?
We're not going to be able to. The NHTSA is going to have to. They're going to have to make requirements for connectivity, and we're lobbying for that as well. I mean, we signed the petition. They're going to have to do. It's going to have to come from the government on the connectivity side. The other thing we can do, that I can do, is we can stress the public transportation side of this.
Yes.
I can control the buses. I can control garbage trucks. I can control the traffic controllers and pedestrian, and push on that as hard as I can and try to get them out there. My agency, our next big project we're trying to do is mobility as a service. Now, the first project is going to only be serviced in one parking lot, but we're looking at getting 6 automated vehicles out there to service downtown for those people who are in that parking lot. So now if I start having vehicles out there and they're connected, they're giving me data. So I'm going to have to do a workaround, is the best way, because I just don't think we're going to be able to rely on them short of the U.S. government saying you have to do this.
Yeah, I'm thinking about the full benefit of the system.
Yeah. As I said, the OBUs, onboard units, don't do it. Hire a professional. They're a pain. I don't want to keep you guys here longer than you need to be. Let's see what we got here. These are just more organizational things, and I'm going to give you tips that if you go out to work in the industry. The first one is we got passed a procurement policy for experimental pilot projects, which means I can sole source. I can make a phone call to University of Arizona and I got them under contract for $50,000 without having to put an RFP on the street and go through that whole process. If I had to put everything out and bid it and go out through that process, I never would be able to do anything. I mean, we'd still be in phase 1. So if you can, trying to have some sort of experimental pilot procurement policy. And I know that sounds boring and it's not like part of the fun engineering, but that's what's going to make your life miserable when you get into work. But that really good. The other thing on this new technology stuff, fixed fee contracts. Transfer the risk to the vendor. You want to make sure, yes, you're probably paying a little bit higher per unit than you would if you really negotiated hard, but having an upside limit where you know that you're protected and it won't go higher than that really helps you on your budget side. And transferring the risk then is on the vendor. They have to produce for the money they're getting. They're only getting so much on a fixed fee contract. So those are 2 issues that I found really, really helped. I know this is going to sound weird because in this technology world, face-to-face meetings, something people don't think about anymore. We get more done in face-to-face meetings, even if it means flying to Austin or going to D.C. We're able to get more in a day face-to-face than 50 conference calls or what do they call the little? It's slipping my mind. But conference calls, it just doesn't seem to work. Maybe I'm old school, but the face-to-face are much more productive, and we found that it really helps, especially with this experimental stuff. Because on a conference call they'll glaze it over with some term, and when you're face to face, you could actually sit down and drill in a little bit and try to find out what's really going on. And then let me see if there's anything else here that I want to. And that's it. Questions?
This is more of a comment. Some of us that have been here for this whole Smart City series That's the second time procurement has come up as being a crucial issue.
Oh,
We
yeah.
had a guy from the city of Los Angeles, and he was from the tech sector, and he was brought in to kind of synthesize all this and help the city of LA get a smart cities program going. And after analyzing the whole system, he chose to start with procurement.
Yeah. It's
And
huge.
he totally streamlined the way they took bids for this type of things and how they advertised and cut the process way down, because he found that the leading firms, they don't want that 3 to 6 month procurement process. They move way too fast for that.
You can't, and the other thing is, a lot of times you're on deadlines, and if you have to put something on the street, I don't know if any of you guys have gone through a procurement process, but are you familiar with the term design build projects?
Yeah.
I mean, my God, we just did one now for a safety project, about $15 million. Between all the presentations, all the meetings, all the alternate, they're each allowed to provide alternate ways of doing things, and then your Q&As where you have to meet with each one of them. It took like 8 months to get this thing under contract to try, and we were just basically putting the barrier in the median. So yeah, I mean, with this project, there's no way we could have gone through that and gotten anything done, because the other thing that happens too is dealing with procurement, the procurement department is new needs come up in these projects like that daily. You're sitting in a meeting and don't even realize, something you didn't even realize when you put it together. Then trying to go through procurement and getting them to put something on the street is like 5 weeks of convincing them that they need it. And all that time, you're losing time. And all that time on those fixed fee contracts, your vendors are losing money. Because the best way to stay on budget is to get something done as quickly as possible. If you prolong the time, it gets nickel and dimed along the way, and the next thing you know, you have no budget left and you haven't gotten anything done. And the procurement doesn't help. But yeah, I could 100% see how that's why I put it in mine as a lesson learned. Most places can't do that, but if you can get that sole source for that, it would definitely make a difference. And that'd be something to remember, when you're going out for your jobs. Yeah.
Hi, Bob. We were curious. I'm a CEO at a startup company, a startup. We are working on an SBIR project funded by US DOT.
Mm-hmm.
So in this project, we're developing a technology that will allow connected vehicle deployment for the rural areas.
For what?
For the rural areas.
Rural areas, okay.
Yes. So I was wondering whether you will suffer this problem. So what is the coverage area of this pilot program? Approximately.
Ours, we're in a central business district, so it's about two by two. Oh, thank you very much.
Sorry, I gotta go.
It's like 2 miles by 2 miles. The one that you want to talk to is Wyoming. Their pilot is doing 400 miles of I-80. And most of their deployment is truck fleets and weather related. But they are providing connected technology over a 400-mile area. They were selected specifically because they're rural area and stuff. Tony English is the lead engineer for that project on the.
So do you think the drivers will have this problem, abrupt change when they are out of this connected vehicle coverage area? So their vehicles are communicated with infrastructure constantly, but suddenly they go out of this coverage and no connection at all. So do you think this abrupt change will affect the driver?
Yeah, I mean, I could actually see a need in rural areas. Very early in my career, one of my first jobs I had to do was I did fatal crash reviews for Alligator Alley. Mm-hmm. And the amount of fatal crashes that occurred on sunny, dry days amazed me. I was expecting it to be weather, but most of them were sunny, clear, dry days. And I could see how connected vehicle technology could help keep you on track and keep you awake or give you a message of something. So I can see how that can work. We're moving right now from the connected to the autonomous for the next project we're trying to put a proposal together for. And right now Siemens has, we call it the pole, but it's got all the inputs for the autonomous vehicle to contact back to the infrastructure. Most of it's redundant because a lot of the autonomous vehicles have this in there, but it gives a safety margin. But right now, for 1 mile of road, I would need 15 poles on each side. That's ridiculous. It's not going to happen. I mean, you're basically building a wall. But my point is, in 6 months, that will be 7 on each side, and and in 5 years, it will be 1 on each side. And that, once the private sector knows where they need to go, they're very good at getting there. I went to university. My undergrad was at University of Wisconsin, and we had to take a natural resources class. Everybody in the state of Wisconsin has to take a natural resources class. And I'll never forget, the professor said this, and it always stuck with me, is one thing that humans are really, really good at is screwing things up. We mess everything up. But the one thing we're better at is fixing it. And that's the way that I'm thinking about things. We have problems out here, but the one thing that humans do better than anything else is fixing them and come up with solutions and things that work, which is basically what he was saying was at the end of this course, that all is not lost. We're not, heading down the apocalypse. We will we'll figure out ways to correct problems. And it's the same thing that you're talking about there in the rural areas. How do you do it over those long distances? They'll figure out how to do it. Like right now, Sirius XM with satellite radio. Can we use satellite to do that?
So in our technology, what we are doing is we are placing unique signs that can deliver a message to the vehicle. So there is an onboard machine vision based system that you place in your vehicle, and it will recognize the message and basically transmit either to audio or directly warn the driver. So, for example, in a construction area, as you mentioned, it can deliver the geometry of the construction area, and mapping message can be sent easily. So we were trying to get more input on this. Like, if you have time, you can watch our prototype video. Maybe you can say like
visual products.
If you want to talk to him after it's up to you.
Yeah, I would strongly recommend if you give me a card, I'll hook you up with somebody in our somebody like Steve Nova said, who's our technical lead or something like that, who can describe that more.
We need kind of like operational insight, like whether this is useful or whether this is a viable solution, whether this is something worth to test. I think you're
the guy, basically.
Yeah, I'll have to pass it on. Yeah, please.
So I had a series of questions. If let's see.
Sure.
So you talked a lot about GSRC and 5G. So do you have anything, any argument against GSRC? Because there is a debate going on, as you rightly said. Do you think, or what are those things? What is against GSRC?
Against the SRC? I think that the telecommunications firms would argue that 5G can do everything that the SRC can do, and it's 5G is more the future. It would be more cost effective ultimately to do 5G because the SRC you have to purchase individual units and stuff. The downside is, then you start getting into, well, what about security? TSRC, I know it's secure. The other thing that comes into it too is, from an agency side, I don't want to be beholden to Verizon. And if Verizon goes down, am I screwed? Excuse my language, I'm sorry. If Verizon goes down, do I have a problem? I mean, 911 systems have gone down before on that. The other thing is, and I know this is an engineering group, not a land use planning group, but in the 1990s, it reminds me of the casino situation in the 1990s. In the United States in the 1990s, all these little communities decided they were going to put gambling in casinos, and it was going to solve their revenue problems. So they were going to control it. It was only going to be from Thursday night at 8 until Saturday morning at midnight. And the casinos at first were very successful. Then the casinos said, we need more infrastructure, we need roads, we need this, we need that. So the cities then bonded and built them. Once they were committed to paying for those, the casinos said, either you let us operate 24/7 or we leave. They were so far down the road, Atlantic City is the biggest bankrupt model for that. They were so far down the road and so committed that they had no recourse against just giving them what they want because we need them to stay. And 5G and the telecommunications scares me in that regard, that once I get so committed down there, does Verizon then set the rules? And I really have no other way of providing my mission, transportation and public safety, because I need them. With DSRC, it's my equipment. It's in the roadway. I mean, I still have a large cellular bill every day from the cellular. We have some areas, the RSUs, we can't use fiber, so we have cellular. So I mean, we're still paying them. But if they go down, I got another way of doing it. I can control it. I have redundant systems and stuff. 5G scares me in that regard, that if we get so far down there, I'm going to really date myself now. I was in the Army in '86 to '90, back before the Berlin Wall fell. That's how old I am. But one of the things that we always taught back then, was single point of failure. One of the problems that the Soviet military had was single point of failure, one point of control, one point of, if you could knock that out, everything else fell apart. And one of the things that we didn't have was that down to the lowest level, you could take over, take control, and get things done. And that was the tradition that you saw. My point is, it seems like we're moving to single point of failure. And what happens if that single point of failure goes down? It just seems to me that we traditionally have, in the United States anyway, stayed away from that. We wanted redundant systems, smaller regional areas, so that if something goes down, the whole thing doesn't go down. And 5G just screams to me that we're moving to that single point of failure, that if they take out a satellite, or if a satellite fails, sorry, I don't mean to talk that way. I mean, if a satellite fails, do we lose half of the United States in coverage of public safety in terms of signals and stuff like that? So, but then again, like I said, and the only reason I gave you my experience in the military was just to give you my context, where I'm coming from. There's a lot of people I talk to today that don't agree with that. They think that, that they'll give you other reasons. But from my perspective, that's what scares me about 5G, is I don't like being reliant on one thing.
So my second question.
Sure, please. I'm sorry.
Yeah.
So it was regarding BSM. So when you showed that chart, so I think per day how many BSMs were being broadcasted. So I think this is the count of the messages being broadcasted, or do you also keep the count of the messages received by the caller?
Yes, we do. Very good question, but we can't read that yet. We're having problems with the OBUs reporting back. Right now, we can do firmware and software updates over the RSUs. They're supposed to be able to also take the data back, and we have not solved that problem yet. And we're getting close, supposedly. At least they keep telling me. But yes, we are supposed to be able to do that, but we can't right now. I'm hoping that the next test will be in December, that we're able to solve that. But you're 100% right. We should be able to do that. And if we don't, then we're going to have to rethink the pilot in terms of how do we get the data out of the OBUs.
Definitely. And also I was thinking, I'm not sure how Qatar is going to analyze or what is their plan, but once a driver receives that BSM, based on that information, that when the light is going to turn green or red, what action does he or she take? That information would also be needed to analyze how effective these BSMs are, or strategy on a microscopic level. On a macroscopic level, you can do study of traffic density and efficiency, but on a microscopic level, safety-wise, efficiency-wise.
And we're basically looking at our technology, not from the micro, but from the macro. How does this technology impact the performance of a corridor? So Meridian Avenue as a whole, how does that work? 7, 8 years ago, there was a pilot called the Ann Arbor Safety Pilot. Safety pilot went into the individual movements, and they had cameras in the cars and all that. That dealt more with that. We're looking more at corridor-wide performance measurement to see how it works. So for us, we're going to look at the total number of crashes in the total number of rear-end crashes in a 6-month period. Did it decrease versus what we saw over the last 5-year average, or something like that?
I agree. A quick comment on this one. Let's assume hypothetically, if all the 1,600 drivers saw those messages but did not do anything, did not act, then basically information was there, but no action was taken. So
Right.
in that scenario, nothing should change. Safety, efficiency, everything. So some kind of behavioral study needs to be, I think, incorporated. Like how many percentage of drivers actually?
I don't have the budget for that.
These are university type questions.
No, these are all good points. And if you're familiar with US DOT, ITS Joint Program Office is where they run all these out of Turner Fairbanks Research Institute. I'm sure they've got projects that are in other areas that are going on, looking at some of that stuff. Mine is specific to corridors, and that's it. My grant was $17 million, and we put in a $4 million match, so I got $21 million to do this, and that was beyond what we were supposed to look at. But it's a good point. Yeah, please.
Last question. So basically, I realized, this is very challenging, and with all these agencies and a lot of hard work. But from our university point of view, I think this provides us with a lot of research opportunities. So we as UCF, as Civil Engineering Department, we would love to collaborate. And is there any way we can or other?
We wanted to. Actually, we asked to be part of your SunTrax, which UCF I think is a part of, isn't it?
Yeah.
Yeah, we wanted to, and they told us no. They were trying to keep it Orlando-centric. They didn't want
the vehicle.
They didn't want to mix.
The CV testing grounds.
Yes, right?
Yeah, the SunTrax one. Yeah,
That's the Florida Polytech, right?
Yeah, we have
Yeah, but I mean, they ultimately wanted to do that to
the autonomous testing bed.
It was just Orlando. So
Yeah.
because we actually called and said, hey, we'd be more than happy to work with you. We're going to work with District 5, trying to do something along the I-4 corridor, connecting between our pilot and
I
theirs.
think that was a DOT decision. The District 5 decision. I don't think it came up to us to select.
No. It didn't come from you guys. You guys were on the list of.
Yeah,
I mean,
yeah.
but I'm just saying we've been trying very hard to collaborate. I mean,
My question was specific to this project. So let's say in a year or two, when Qatar, makes sense of all this data, would it be possible for us to, let's say, look at the data, analyze some things,
Yeah.
do some research?
Yeah, Dr. Cicinio Kankis over at Qatar would be the person to contact on that. But yes, we definitely would have no problem with that. We're actually.
Is it open source data for open research? Or?
I know we'll be supplying data to the USDOT public source. So, yeah, I would assume that we should be able to do that.
Okay.
But yeah, that's not a problem.
If you wanted to get our vehicle NOVU, would it be possible?
Excuse me?
If you want to volunteer for our vehicle to be,
To install it.
An OBU? Sure, we can do that. I don't know if it can. We'll be a little bit out of the study area, but we, definitely. I don't know how many RSUs they have over here. But I mean, I would have to probably go through UCF on that, not as an individual company, but through UCF if they wanted to do something with us. I'm sure we could work something out. I know USDOT wants us to collaborate and wants us to work with others on it, so we have no problem with that.
Okay, I think in the interest of time I'll close the questions. But thanks so much, Bob.
Yeah. And by the way, we give our academics, Dr. Kakas and Achilles, a hard time. We're teasing mostly, so just please, I don't want you all to get mad at me because I was giving you.
We work with the industry, so we know.
But thank you guys very much for having me, and we'll work any way we can.
Thanks so much for your time.
Sure.
It was very nice.
And I'm sorry if sometimes I go a little bit off tangent.
No, it's good. It's good. it's all good. I didn't tell you before we were recording.
You were?
We were recording.
Oh, great.
You did. So I think we stopped off after 4:30. But yeah.
Oh, thank
Very
you.
nice meeting you. Yeah.
Oh, nice meeting you too.
Very interesting. You know anything because there are a lot of open questions.
Oh, there are a lot, yeah.
The study can answer. And
I would have used a different example for my single point of contact then. If I would have known it was being recorded. But yeah, no, that's single point of failure I was talking about. Yeah, no, they, you know, what happens with this, I'm not real sure. We do think though that the connectivity is your entry level technology to smart cities. But bottom line is they're going to have to show cities and communities that there's value in doing this besides the Starbucks crowd who thinks it's cool. I mean, and that's right now pretty much all we've got are people saying, wouldn't this be great? But we don't have any data showing that it would make any benefits at all. So it's going to be interesting. Right now it's all in the test stages. So it's either going to work and it's going to spread, or it's going to go away and we'll be moving on to the next thing. I mean, and we've seen that before. You know. So anyway, thank you for having me. And I apologize for being late. And, you know. Yes, sir.
Hi, just wanted to quickly introduce myself. So,
Sure.
I just joined UCF in transportation group as an assistant professor.
Okay.
And your talk is very, very interesting to me. And I actually try to look for, try to understand the perspective from a public agency like your organization. So there's always a trade-off, right, between short-term and long-term goal. Like when you try to adopt any technology, you kind of need to balance these two.
Yep.
And I just want to kind of know a little bit from your perspective, like when you're making decision, for example, when you try to push forward a project like this one, what's your trade-off? Like, it seems to me like public agency focus very much on the reliability, or maybe like a little bit short-term return.
Well, number one is safety. We're looking for safety and efficiency, just as I said, because as a toll road, we're looking for technologies and innovations that can give our users a better, safer ride, and that's what drives us on that. But yeah, there are trade-offs. One of the things we said on this was we didn't want to do a demonstration project. We wanted to try something that actually solve real problems on that. And, the way I look at it is, we build it into our work program. I mean, if you work at a public agency, work program is everything. That's where it is. And if you get it into the work program over, 5 years, I mean, we have $1 million a year for AVCV right now in my work program going out the next 5 years. That will be, hopefully I'm trying to use it for matches to other US DOT projects so I can leverage that $5 million into, 20 million Fed plus R5, gives us enough to do something.
Yeah.
And it's expensive to try to do some of this stuff. I mean,
and especially if technology change, everything kind of you need to
You
update and
research
keep
and update.
updating. So
you're in the phase 3 now, or
Excuse me?
are you in the phase 3?
Yes, we are. Technically, we are. We're still having problems, though. I mean, FTA Federal Transit Administration sent a whole bunch of people yesterday, gave them this same talk, took them out. Damn thing didn't work. You know what I mean? You're sitting there going, "Come on, guys, you're killing me here." But what ends up happening is they go in and fiddle with the code, and they solve one problem, and it crashes 3 other things. And then they got to sit back and go, okay, what do we do? And it causes. I don't think people understand how difficult it is to do a lot of this, a lot of that stuff.
implementation is, I think.
I never. I mean, and you deal with public agencies. You're dealing with groups that have done. I mean, how many road resurfacings have a DOT done? Millions. So they know exactly how much it's going to cost, how long it's going to take, everything. This is all brand new, so you get a lot of skepticism because it's like, why are we doing this if I can't show any value?
yeah.
So we'll see. I mean, the generations coming up, seem much more.
Open to.
Well, they seem to like this, and they seem to want this
Doing
type
this,
of,
okay.
of technology. They want the connectivity. They want to be able to. I think it's all started with this. They want to be connected and stuff like that, so they understand that. Well, to them, there's a value. So they're gonna. When that generation starts moving into more of the decision makers, they'll start making decisions more on that because they're used to it. Right now, you still have a lot of guys